Matthews again for their wonderful presentation. Thank you. So the next presentation is paper ID number 10. The title is Blockchain Supported Design Tool on Building Element Scale. The authors are, and again, excuse me for my inaccurate pronunciation if there's, Goran Sibenik, Marijana Srankovic, Thomas Prinendo, Martin Kayer, and Wolfgang Kastner. Welcome.
Thank you. So hello, everybody. My name is Goran Sibenik, and I'm from the Institute of Interdisciplinary Construction, Construction Process Management. And this is the work that we do on the project BIM Design, or BIM Digitally Signed with Blockchain. And we're doing it in cooperation with another Institute of Computer Engineering, also from Technical University of Vienna. So the title is Blockchain Supported Digital Tool on Building Element Scale. So first, let me mention some problems which you probably already know from the construction industry. So interoperability between the proprietary programs is slowly developing, but it's still not perfect. We have heterogeneous design workflows, and often the stakeholders in these design workflows change. We also did not reach the standardization of data and processes which we would like. But on the other hand, we have constantly developing digital technologies. We have all the digitalization of the whole construction industry is slowly advancing. And in the research already, blockchain and smart contracts show their potential. So this research aims to answer how to manage data on the building element scale to be supported with blockchain and smart contracts. So state of the art of the data exchange, we usually use proprietary software tools for our tasks and all the different stakeholders. In this research, we try to investigate 4 different types of data exchange. One was file-based data exchange with IFC format. Then we used also a platform which uses IFC data. Then we tested also a common data environment, which is recommended by the ISO 19650. And we used Speckle for that purpose. And we also tested a solution from the previous project, which uses Mongo database for the data exchange. All of these solutions would benefit from better digitalization, automation, and traceability. So how we did it, you can see here the overview of our method. So we can divide it in 2 parts. One is we use the traditional building design process or existing BIM design process. And with task technology fit, we try to see which tasks could be covered by technologies which are different data management solutions, which I just mentioned, and the blockchain. So with a task technology fit, we identified 9 tasks which could be supported by blockchain technology and data management solutions. So those are to allow digital assignment of tasks in the design phase, to partially automate the assignment of tasks, for activities, to map perform activities storage, to automatically report the performed activity, to relate activities to a corresponding asset, to guarantee the communicated asset based on its content, to address assets on document and building element level, and to validate activity based on predefined rules. Activity in this sense means atomic element of the design process or a single step in the design workflow which is performed by a specific actor. The asset is not limited on a building model, so we use also like a single object, but it can be also an alphanumeric file or a single message maybe even. And based on these tasks, we then with the software architecture analysis method tested 3 scenarios to define the specific requirements which are needed from this system architecture. And those were Those scenarios were like, the first one was the approval of new design, which included the investor who assigns the general planner, who assigns the domain specific planner to make a new design, and then it goes back for approval. Then we had approval of structural element, which is an object building element based process where architect and structural engineer communicate. Then we had a scenario, the most complex one with cost calculation, which was BIM based. So we had BIM manager who actually coordinates domain specific planners to arrange their models for cost department, and which should be approved by a general planner. And then we identified 11 of requirements, which are sender information, receiver information, relation between an asset and an actor, validation of assets on file level, validation of assets on object level, authorization of an asset as file, authorization of an asset on object level, relation between activities, report on performed activity, relation of activity and asset on the object level, and validation of activity and asset on the object level. These requirements we then tested or analyzed in these 4 data management solutions. So file-based with IFC, BIM server, which uses IFC data, then Speckle, which was a common data environment solution, and our own MongoDB solution. And we saw that they already support some of these requirements, but none of them supports all of them. Finally, we decided to use Speckle because it's an open source available solution. Also, it resulted from not our research project, and we decided to use blockchain with Speckle. So this is an overview of our blockchain system architecture with Speckle. So I'll just shortly explain it. We used Revit as a design tool, and after the end user uploads the design on Speckle, all the activities on Speckle are recorded on blockchain. Blockchain we developed with baseline protocol. So the other blockchain solutions, we used Ethereum in this case, but other blockchain solutions could also be added with the baseline protocol. And we also added an additional module which can support storing emails on the blockchain. So I'll just show you a few user interface slides from the developed application. So each session starts with a so we could authorize each activity which was performed, and each activity is then stored on the blockchain. So a user is able to assign a task to another user, and this task is then immutably stored on the blockchain. Then another user receives these tasks and can, then it is expected that the user uploads a changed or a new model. Here we can see this is actually the connection between our application and the Speckle. So the Speckle offers also to trace a single object or the changes in the model. So it's not necessary that the whole model is uploaded every time. Then the users can also communicate between each other, and the models or the messages are not stored on the blockchain, only the hashes, which are unique for a specific. The messages or the models are not stored on the blockchain, only the hashes, which are unique for each message or the model. And finally, the authorized users could also, in the end, analyze the workflow, which could serve well for the optimization of workflows, because at the moment we don't have these informations how the design how the design workflow actually looks like. So what is the novelty of our approach? We analyze the design workflow with specific intention, with a specific implementation in order to support the existing design processes. We also consider multiple data management systems, and we also realized it with Speckle in the end. So we we analyzed actually three fields, which are building design management, data management systems, and blockchain. And usually these three stuff are not investigated at the same time. So this research, of course, has some limitations. And first one would be applicability, because the level of digitalization which we investigated or which we considered is already a bit too advanced for the industry, especially for some domains. We also have only investigated 3 scenarios, and we did not consider how expensive cost-wise and energy-wise the blockchain at the moment is, although this community is working on improving that. So the next step in the research would be to directly connect the blockchain solution with the proprietary solutions. So for instance, Revit, so we would avoid any overhead work. Also, we would like to consider more scenarios and verify our approach in the practice. Thank you.
Thank you, Goran. Next presentation. Is there any question from the audience? Okay, I'm not hearing any question. So maybe I can ask you a quick question. Blockchain.
Yeah.
Is there a question?
Yes. Thank you for an amazing presentation. So my question is, what do you think that could be the principal risk if you decide to implement the blockchain in a project in a real life?
So can you repeat the first part?
The principal risk if you decide to implement blockchain?
At the moment, the principal risk is that it costs a lot. So it is not a risk. It's not really, at the moment, it's not very feasible because it requires a lot of energy to be maintained and to be and to pay for the transactions. But the risk, I don't know, there are still some security issues with blockchains. It's still a field in development. Our project is testing in which way it could be used in the design phase. And at the moment, we don't think that it's feasible. That's the biggest problem. The risks are all the risks which exist with blockchain. However, we try to use it, therefore, we try to use it on the public blockchain, which then provides better security. And only at the moment, there are only risks which exist with that. And of course, we have these risks which, because we don't store the whole model on the blockchain because it's just it's too heavy, that we lose both copies, for instance. In this case, if we communicate something and the sender and the receiver have, or if they are multiple, they can be also multiple copies, but they could both get lost, for instance. But those are quite human factors. However, we still have the proof that a single model was there at some point of time. So if one user can prove it, then the other one could. So the biggest benefit would be actually this immutability, or you don't, you're not relying on a specific proprietary provider. But as I said, much as I know at the moment are from the general blockchain risks, which are technological.
Okay, thank you.
Okay, and we got a question in the chat. Thanks for the presentation. So this is from Giovanni Barrios. This kind of management is addressed to MEP design. That's a question. Or is it going to be able to manage architectural design too? How does the changes control management work if the project scope changes? How does the updating process work?
At the moment, the data management system which we use is Speckle. So Speckle offers different ways of doing Speckle manages changes itself. So it's similar to Git. So it has streams and which can be referenced then on the blockchain. So it's not necessary to use the whole model every time. So, but that is provided by Speckle actually. The chain, and it also involves architecture and MIP. So all the programs which are supported by Speckle, and I think there are 11 at the moment.
Okay, great. Thank you for your answer, Goran. Again, we have to move on to the next presentation. Thank you again for your very interesting blockchain platform. So the next presentation is paper ID number 26. The title is Digital Transformation in Asset Management, a case of BIM adoption in New Zealand local government